How's it going, guys? Today in this video, we're going to be going over Module 10.1, Day 1, Simplifying Rational Expressions. So as a quick overview of everything we're going to be going over in Module 10, is that we're still going to be dealing with rational expressions. And remember, rational expressions are basically just polynomials or integer values or expressions over other integer expressions. And what we're going to be doing in this module is that we're going to be learning how to simplify, add, subtract, multiply, and divide them. Honestly, I don't think it's anything too new that we haven't learned already, but we're just going to be taking everything that we've learned in the past few modules, and we're going to be applying it in different ways. Okay, so we have something, a new vocabulary word, excluded values. And what an excluded value is, it's just the value of an expression that turns the whole expression undefined. So basically, we're going to look at the denominator and see what values or what values of the variables turns the whole expression into an undefined function. So if we think back at Module 9, that's essentially going to be our vertical asymptotes and our wholes of the expression. Okay? So let's actually go ahead and actually do an example now. I think everything I've said will be explained best while we do an example. So we have this rational expression, x squared minus 1 all over x minus 1. And what we want to do with it is we want to factor it and figure out our factored expression. And then we want to simplify it, and then we're going to figure out our excluded values of x. So first thing we're going to do is factor it. So we're going to factor out the top and the bottom of this fraction. So x squared minus 1, that's a difference of squares. So that's going to factor out into x minus 1 times x plus 1. X minus 1 on the bottom is already factored out, so we don't need to do anything to it. We can just bring it down on the new fraction. So our factored expression is just going to be what we just wrote over there. X minus 1 times x plus 1 all over x minus 1. And for our simplified expression, what we're going to do is we're going to look at this expression and we're going to see, can we cancel anything out? Can we simplify the expression anymore? And we see that we have an x minus 1 on the top and the bottom, so we can actually cancel those out. And when we do, we're left with x plus 1. This expression cannot be not canceled. It can't be simplified anymore from here. So that means that this is our most simplified expression of our rational expression from the beginning. And now we're going to look for our excluded values of x. And to figure out what our excluded values of x are, is we're going to go back to our factored expression. We want to go to our factored expression before we actually simplify it or cancel anything out. And when we do, we're going to look at the denominator. And when we look at the denominator, we're going to look at every single fraction, or sorry, not fraction, but factor, and we're going to set each factor in the denominator equal to 0. So the only factor we have in the denominator of this factored expression is the x minus 1. So we'll set that equal to 0, and we get that x equals 1. So our excluded value of x is 1. Or in other words, x cannot equal 1. So our excluded values of x is technically 1. But that means that x cannot equal 1. Okay, let's go on to number 2. Number 2, we're going to do the same thing. We're going to factor out the top and the bottom. The top, we have x squared plus 7x plus 12 all over x plus 3. If we factor this out, we get x plus 3 times x plus 4. 3 times 4 gives us 12, and 3 plus 4 gives us 7. And the bottom is already factored out for us, so we can just rewrite it. We cannot factor it out anymore from here, so that means that this is our factored expression. And now to figure out our simplified expression, we're going to see if we can cancel anything out from our factored expression, and if we can simplify it anymore from there. The only thing we can cancel out are these x plus 3s. So when we cancel those out, what we're left with is x plus 4. We cannot simplify this anymore from here, so our most simplified form of the function, or of the expression rather, is x plus 4. And now to figure out what our excluded values of x are going to be, is we're going to look at the factored expression, and we're going to look at, namely, the denominator of the factored expression. So we'll set every factor in the denominator of the factored expression equal to 0, and see what we get. The only factor we have in the denominator of the factored expression is x plus 3. So we'll set that equal to 0. And when we do, we get that x equals negative 3. So our excluded value of x is going to be negative 3. Or in other words, x cannot equal -3. Now for number 3, we have 2x squared plus 9x plus 10 all over 2x plus 5. So we'll still go about it the exact same way. We're going to factor out the top and the bottom. For the top, we don't have an exponent of 1 in front of the x squared. So that means we're going to have to do the box method or the split the middle term method or whatever you like. I'm going to use the box method. And so the top of our x is going to be our a times our c, which is 20. The bottom is going to be our b value. And the expressions in the middle are going to be factors of 20 that add up to give you 9. That's going to be 5 and 4. We'll go ahead and draw our box. In the top left corner is our ax squared term, so 2x squared. The bottom right is our c value of 10. In the diagonal will be 5x and 4x. The GCF of the first row is just x, and x times 2x gives us 2x squared. 2x times 2 gives us 4x. Now x times 5 gives us 5x, and we see that 5 times 2 does give us 10. So our factors that we got from our box method are correct. So our factored form is going to be 2x plus 5 multiplied by x plus 2 on the top. And now for the bottom, we have 2x plus 5 in our original expression over here. 2x plus 5 cannot be factored down anymore, so we can just rewrite it on the bottom. So we get 2x plus 5 on the bottom. And now for our simplified expression, we're going to see if we can cancel anything out. We have a 2x plus 5 in the top and the bottom, so we can cancel those out. And when we do, we're going to be left with x plus 2. We cannot simplify this anymore from here, so that's our most simplified expression of this rational expression. And now for our excluded values of x, we're going to go back to our factored expression, and we're going to set every factor in the denominator equal to 0. The only factor we have in that denominator is 2x plus 5. So we set that equal to 0, and we get that x is going to be equal to -5 over 2. Just divide the 2 after we subtract it, and we get x equals -5 over 2. So our excluded values of x is going to be -5 over 2, or in other words, x cannot equal -5 over 2 for this rational expression. Either one of those are okay. Now for number 4, it's going to be the last example so far. So we need to figure out our factored expression. So we're going to factor out the top and the bottom. For the top, we have x squared plus 8x plus 15. That's simply going to factor out into x plus 5 times x plus 3. 5 times 3 is 15, and 5 plus 3 is 8. That's going to be all over 3x minus 2. Okay, so now that we factored out our expression, we're going to see if we can simplify it any more from here, or if we can cancel anything out. There's no factors that are the same in the top or the bottom, so that means our factored expression is our simplified expression. So we just go ahead and rewrite it over here. So our simplified expression will be equal to our factored expression. Okay, and now we need to figure out what our excluded values of x are going to be. So again, we're going to go to our factored expression, and we're going to set every factor in the denominator equal to 0, and see what we get. So we solve this for x, we'll get that x equals 2 over 3. So our excluded value of x is 2/3, or in other words, x cannot equal 2 over 3. So now we're going to talk about how to write equivalent rational expressions. You can read that little excerpt on your own if you want to. I'm going to go straight to the problem. So we're told that we need to write an equivalent rational expression. Equivalent means that it has the same value even though it looks a little different. Okay? So we need to write 5x all over x plus 3, or rather we need to rewrite it to have a denominator of x plus 3 times x plus 5. So when we're comparing the two denominators, x plus 3 with x plus 3 times x plus 5, the only thing missing on the bottom of the denominator is the x plus 5. We need to have x plus 3 times x plus 5 on the bottom. And to get that, we need to multiply the bottom by x plus 5, since x plus 3 times x plus 5 equals x plus 3 times x plus 5. But we also have to make sure that our new rational expression is going to be equivalent to our beginning rational expression. Or in other words, we cannot change the value of the expression. So the only number that we can multiply an expression with and make it keep its same value is 1. So we need to make sure that whatever we multiply our original fraction with, our original rational expression with, is equal to 1. So that means if we're multiplying the bottom by x plus 5, we need to make sure we multiply the top with x plus 5 as well. X plus 5 over x plus 5 is 1, and 1 times anything gives you the same value that you multiplied it with. So in this case, we're going to multiply 5x over x plus 3 with x plus 5 over x plus 5, and we get that 5x times x plus 5 all over x plus 3 times x plus 5 will be our equivalent rational expression that has the denominator that we want. Right? So that's our answer for number 1. And now for number 2, we're going to do the same thing. We want to write an equivalent rational expression of 5 over 5x minus 25 with x minus 5 times x plus 1 in the denominator. So before I ever start messing with rational expressions or changing the denominator or doing anything with it, I'm always going to factor it down and simplify it as much as I can. Simplified expression is always going to be easier to work with. So I'm going to simplify this expression some more. In the denominator of this expression, I see that we have a GCF of 5. So I'm going to factor out that 5. And when I do, I'm left with 5 times x minus 5 in the bottom. And after that, I see I have a 5 on the top and the bottom. So they cancel out. And I'm left with 1 all over x minus 5. So that's my simplified expression of the original expression that we're given. So now I need to rewrite 1 all over x minus 5 to have a denominator of x minus 5 times x plus 1. So if I look at the denominator of my current rational expression, 1 over x minus 5, the only thing I'm missing on the bottom is an x plus 1. I need x plus 1 times x minus 5. And if I have an x minus 5 currently in the bottom, I need to multiply it with x plus 1 to get the x minus 5 times x plus 1. And at the same time, I cannot change the value of my current rational expression. So I need to make sure that whatever I'm multiplying it with, I'm multiplying it by 1. And all that means is whatever you multiply the bottom with, we multiply the top with as well. So we have to multiply 1 over x minus 5 with x plus 1 over x plus 1. And when we do, we get x plus 1 on the top, all over x minus 5 times x plus 1. So to recap, whatever you multiply the bottom with, you have to multiply the top with to make sure that it stays equivalent. And at the same time, whatever you're missing in the bottom, that's what you're going to multiply the fraction with. Okay? For instance, on this last one we just did, we were missing an x plus 1 on the bottom. So we multiply the top and the bottom by the x plus 1 that we're missing. And that's how we get our rational expression, or our new equivalent rational expression. So let's keep on going. We have number 1 and number 2 now. So for number 1 and number 2, well, rather for number 1, we have x squared plus 5x plus 6 on the top, and x squared plus 3x plus 2 times x plus 3. And we're told that we need to factor this expression and then simplify it. So when we do, or rather, when we start factoring it, the top for number 1 is going to end up being x plus 3 times x plus 2. That's what the top factors out into. And for the bottom, we have x squared plus 3x plus 2. That's going to factor out into x plus 2 times x plus 1. 2 times 1 is 2, and 2 plus 1 is 3. And we still have this x plus 3 over here, so we need to bring it down. So our new factored expression will have written over here. And we're told we need to simplify it. So we're trying to simplify it. We're going to see if we can cancel anything out from the top and the bottom. And we see that we have x plus 3 both on the top and the bottom. And we have an x plus 2 on the top and the bottom as well. So when we rewrite this simplified, we have 1 all over x plus 1. So that's our simplified expression of this rational expression. So I know this question didn't ask us to figure out our excluded values, but I want to go over that anyway. So if we're looking at number 1, and we want to figure out what our x's cannot equal, or what our excluded values of x are going to be, we're going to look at our factored expression. This right here is our factored expression, and we're going to set each factor in the denominator equal to 0. So each factor in the denominator we have is x plus 2, x plus 1, and x plus 3. We're going to set each one of those individually equal to 0. And when we do, that x plus 2 gives us an x value of -2. That x plus 1 gives us an x value of -1. And that x plus 3 that we crossed out gives us an x value of -3. So these right here are our excluded values. So x cannot equal -2, -1, or -3. So these are our excluded values of number 1. We didn't need to find it, but I did want to go over it a little bit. And now for number 2, we have x cubed minus x times x squared minus 1 on the top, all divided by x to the 6 minus x squared. So we're going to factor out the top and the bottom. For the top, the x cubed minus x has a GCF of x, so I'm going to pull that out. And when I do, I'm left with x squared minus 1 on the top. And x squared minus 1 factors out into x minus 1 times x plus 1. And for the bottom, we have a GCF of x squared, so I'm going to pull that out. And I'm left with x to the 4th minus 1. So before I actually try to factor out the x squared minus 1 on the top, I can see that x to the 4th minus 1 on the bottom. That's the difference of squares. And the difference of squares it becomes is x squared minus 1 times x squared plus 1. So I can actually cancel out the x squared minus 1 from the top without actually factoring it out. So let me just show you what I'm talking about. So on the top, we still have that x. I'm just going to rewrite the x squared minus 1 for now. And rewrite x minus 1 times x plus 1. And now for the bottom, we'll just rewrite the x squared. And x to the 4th minus 1 factors out into x squared minus 1 times x squared plus 1. So we see this x squared minus 1 on the top and the bottom end up canceling each other out. So I didn't even need to factor out the x squared minus 1 from the top. So let me go ahead and rewrite this. I have x times x minus 1 times x plus 1 all over x squared times x squared plus 1. And the only thing left to cancel out are these x's, one from the top and one from the bottom. So I'm left with x minus 1 times x plus 1 on the top, and x times x squared plus 1. The x squared plus 1 cannot factor out. There's no sum of cubes. So this is our simplified rational expression. And now for number 3 and number 4. I actually want you guys to try that out on your own. You can go ahead and pause the video for a second, and then I'll post the answers in a few seconds. Okay, so here's number 3 and number 4. This is what you should have gotten. Number 3, it would factor out, the top would have factored out into 2x plus 1 times x plus 7, and the bottom would factor out into x minus 8 times x plus 1. And if you tried to find your excluded values, you didn't need to, but I decided to anyway. You would have gotten x cannot equal 8 or -1. Nothing really cancels out from the top or bottom, so that's what you're left with. Okay? And now for number 4. Number 4, we get x squared minus 1 on the top. That factors out into x minus 1 times x plus 1. And the bottom gives us 2x plus 5 times x minus 1. And when we factor that out, when we simplify it anyway, and x minus 1's cancel out, and we're left with x plus 1 on the top and 2x plus 5 on the bottom. And if you tried to find your excluded values, you would have gotten 1 and -5 over 2. Okay? And as I was thinking about it, I think number 3 might have done that wrong. So let me double check it. Yes, this actually did it wrong. What it should be is, just go ahead and redo that completely. I think I rushed it and did it incorrectly. So let's go ahead and just do that together. So for number 3, we have 2x squared plus 9x plus 7 on the top, and x squared minus 7x minus 8 on the bottom. So what we're going to do is we're going to factor out the top. So our A times our C should be 14. The bottom should be 9. Factors will be 7 and 2. We'll draw our box. The top left is 2x squared. The bottom right is 7. And our diagonal is 7x and 2x. The GCF of the first row is x. We get 2x. This should be 1. This should be 7. Two x squared, 7. Yep, that's right. So the top becomes 2x plus 7 times x plus 1. And that's all going to be over x squared minus 7x minus 8. If you factor that out, we get x minus 8 times x plus 1. Yeah, I did that incorrectly at first. Sorry about that. So we'll go ahead and fix the problem that I did. So we see the x plus 1s cancel out. So we'll cancel those out. And we're left with 2x plus 7 on the top and x minus 8 on the bottom. Okay? And if we look at our excluded values, if you wanted to find them, we're going to look at our factored expression right here. And we're going to set each factor equal to 0. So x cannot equal 8 or negative 1. Or in other words, our excluded values are 8 and negative 1. We didn't need to find it, but I just went ahead and looked for it anyway. But our simplified rational expression is just 2x plus 7 all over x minus 8. All right, that's the video, guys. Sorry about the little mistake in the end, but hopefully this helped. Hopefully helped you understand it. And that's about it.